Hi y'all, welcome to week 7 of distance learning. I just want to say I cannot believe that it's been 7 weeks that we've been out of school. I feel like I haven't seen y'all in forever. I really miss you guys. These next 2 weeks, they are going to be new material. This material is going to look scary because it includes notation and symbols that you probably haven't seen before. But the concept itself is really just plugging a number in for another number continuously over and over, okay? So just stick with me. Don't shut down. If you see new notation, it's okay. It's not scary. We're going to be looking at sequences this week. A sequence, you did that way back in like elementary school when you do elementary math and they say like what's the next number in the sequence and you add 2 or something like that. A sequence is just any set of numbers that follows a pattern. There's 2 ways that you can define a sequence. You have an explicit sequence and a recursive sequence. When it says the nth term, the letter N in math usually stands for just some number that you're going to be evaluating. So the nth term, if I say n equals 2, that would mean that I'm looking at the second term. So the nth term really just stands for some number that could be evaluated, or it could be looking at the last number in a sequence. What we're going to be focusing on is just explicit sequences. We're not going to be looking at recursive, we're just looking at explicit. We're going to be looking at 2 different types of sequences. So there's arithmetic and there's geometric. I made a little Venn diagram here so you can compare and contrast the 2. An arithmetic sequence is, think like adding or subtracting to get to the next term. And it's going to increase or decrease by the same amount from one term to the next term. A geometric sequence, I want you to think multiplying. So it has a common ratio. That ratio is just a number that you're multiplying by to go from one term to the next term. So for arithmetic, I want you to think you are either adding or subtracting. And then for geometric, we're going to think multiply. Okay, they are both sequences, so they're both a set of numbers that follow a pattern. It's just that number that you're increasing or decreasing by if you're arithmetic, or that you're multiplying by if you're geometric. So let's look at arithmetic first. An arithmetic sequence is any sequence where you're going to be increasing or decreasing by the same amount. The formula that we're going to be using is right here. So AN, that would be A sub N. If you see a little letter below a big letter, it means sub. So A sub N is just some term in the sequence that you're looking for. So I could replace N with any number I wanted to, any positive number. A1, A sub 1, is the first term in the sequence, or the first number that you're given. D is the common difference, or the number that you're going to be increasing or decreasing by each time. N stands for the number, the term number in the sequence. And then N minus 1 is a previous term. So let's look at this example. I don't know why there's a letter K there. I think that's a formatting issue. So just ignore the K that's there. That should be a dot, dot, dot. Okay. The dot, dot, dot just means that it's going to continue on forever. So let's identify the different pieces here. A1, the first term, is 8. So 8, that's here. This is my A1. To find D, the common difference, let's look at how this changes each time. So if I go from 8 to 5, the difference between those 2 is 3. And since I'm decreasing, I'm going to put minus 3. Let's see if that works between 5 and 2. If I do 5 minus 3, I get 2. So I know that D is negative 3. And same thing from 2 to negative 1. That would also happen if I subtracted 3. So to write the explicit formula, we're going to have, zoom in, I'm going to take the formula from above, just copy that down, okay, and I want this to be written so that A1 and D are replaced with what I have already figured out. So we said that A1 is 8. And my difference, we said, was minus 3. So I'm just going to substitute those two in there. So I have A sub n equals A1, 8, plus D, negative 3, times n minus 1. And then to make it look pretty, I can just put minus 3 times n minus 1. Okay, so the only letter that should be left there is the n. Okay, so that would be my explicit formula. The reason we're writing that is because when it goes to part B, it says find the 100th term using this formula. If I didn't have this formula, I would have to sit there and subtract 3 100 times until I got the number I was looking for. And nobody has time to do that, so we use the formula instead. So I'm going to use this formula. And remember that n stands for the term number. So if I'm looking for the 100th term, I'm just going to replace n with 100. And then we're going to do the math and figure out the number. So you're going to have 8 minus 3 times 99. And if you put that in your calculator, you will get negative 289. Okay, so the 100th term in that sequence would be negative 289. On the next part, it says find which term will have a value of negative 100. So what it's giving me there is A sub n. Remember, A sub n is just some term number, and it's telling me that that term number has a value of negative 100. Okay, so I'm going to use my formula again. And I'm going to substitute A sub n with negative 100. And now, notice this kind of looks like an algebra 1 equation. You have the letter n, and you want to solve for it because n is telling me the term number. So if I solve for n, I'll know which term has that value of negative 100. So I'm going to start doing this by subtracting 8 from both sides. What the majority of you are going to do, and I know because Algebra 2 makes this mistake all the time, you're going to want to subtract the 8 and the 3, but that's not what we're going to do. I can't do that because the 3 that's here is really attached to that set of parentheses that's there. So I can't do 8 minus 3 and turn it into 5 and then divide by 5. So instead, I'm going to subtract 8 from both sides. And then to get rid of the negative 3 that's in front of the n minus 1, I'm going to divide both sides by negative 3. So we're going to have 36, a negative divided by a negative is going to turn positive. I'm going to add 1 to both sides. So 36 plus 1 gives me 37. So that means that the 37th term in my sequence would have the value of negative 100. Okay, now let's look at geometric sequences. So this is now going to be looking at multiplying to get from one term to another. All of the parameters, I guess, in this are pretty much the same. Our new piece here is the r. So the letter r is going to represent the common ratio, and that's just the number that we're going to be multiplying by to get from one term to the next. So a sub n still stands for whatever term I'm looking for. A1 is still the first term. R is the common ratio, or the number that I'm multiplying by to get from one term to the next in the sequence. And then n is a certain term number. So let's look at this example. Again, ignore the k. The k should be a dot, dot, dot. So between 8 and negative 4, think about what would I have to multiply to go from 8 to negative 4. Well, it needs to be a negative because I went from a positive to a negative, so I need a negative sign in there. 4 is half of 8. Whenever we're doing geometric sequences, the r is always going to be a number that you multiply by. You are never allowed to divide numbers here. So even though I'm really doing 8 divided by 2 to get to 4, I can't write it as division. I have to write it as multiplication. Multiplying by 1/2 is the same thing as dividing by 2. So I'm going to multiply by -1/2 to get from 8 to -4. From -4 to 2, again, I'm going to multiply. It goes from a negative to a positive, so I have to change the sign, so I'm going to put a negative. 2 is half of 4, so I'm going to multiply again by 1/2, and same thing from 2 to -1. So that means that r is equal to -1/2, and a1 is the first term in the sequence, which is 8. So when I write my formula, we've got a sub n is equal to a1 times r to the n minus 1. So I'm going to replace a1 with 8. R, we said, was -1/2. And then I've got n minus 1. So this is my formula. Do not multiply the 8 and the -1/2. You can't multiply them together because the -1/2 has that n minus 1 exponent. The n minus 1 exponent only belongs to the -1/2. It is not belonging to the 8. So you're just going to leave your formula like that. If I want to find the 10th term, that means I'm looking for a sub 10. So wherever I see an n in my formula, I'm going to replace it with a 10. So I've got 8 times -1/2 raised to the 10 minus 1. If you type that in your calculator, you're going to get -1 over 64. So -1 over 64 would be the 10th term in my sequence. Okay, this next one is a little bit tricky. This is probably a more pre-AP style question than regular. But which term will have a value of 1 over 512? So this is telling me that a sub n, the value of some term, is 1 over 512. So I have my equation. I'm going to replace a sub n with 1 over 512. And then everything else is going to stay the same. What I'm going to do now is solve this equation for n, because n is going to tell me which term number that's happening with. So to start doing this, I'm going to divide both sides by 8 to get rid of the 8 that's in the front. You can think of this as 1 over 512 times 1 over 8. And that gives you 0.000244. So we have 0.000244. So this step here, I need to get that n minus 1 out of the exponent and get it on the same level as everything else. So think back to last week when you were doing the solving exponential application problems. Whenever you wanted to bring down an exponent, you took the natural log of both sides. So we're going to do the same thing here. We're taking the natural log of this whole thing here. So the trick that we used last time was the power rule, and with the power rule we brought this in the front. The next little thing with this problem that's kind of special, you have a negative sign on your 1/2, and you're taking the natural log of -1/2. In order for this to work, I'm going to have to change this -1/2 to a +1/2. In terms of solving, the negative sign isn't really necessary. The negative sign is just there to tell you that when you're looking at the sequence itself, the sign is going to be alternating between the terms. But in terms of solving for a certain term number, it's okay if the 1/2 is positive instead of negative. The 1/2 is kind of just telling me that I'm dividing by 2 to get from one term to another. So I'm going to make this side's going to stay the same. Using the power rule, the n-1 is going to get brought to the front of the log. And then I'm going to have a positive 1/2 in parentheses now. So if I take the natural log of 0.000244, you get negative 8.318. And remember that the whole goal here is that we're solving for n. So I want to get the n-1 by itself first. So I'm going to divide both sides by the natural log of 1/2. So those cancel. This is going to give me 12 if you put that in your calculator, equals n-1. And then add 1 to both sides, and you're going to get n is equal to 13. So that means that the 13th term in the sequence is going to have a value of 1/512. For my regular kiddos, on your reflection questions, I'm not going to give you something that is going to have that special little trick of changing the sign in it. You are going to have to use the power rule when you're solving, but your question is going to be not a fractional one, so the process is going to be similar, but it's not going to be quite as difficult as it would be for a pre-AP type question. So this is your practice assignment. Notice that you do have down here on the second section, there is a pre-AP extension piece there. So on the second section, it says determine whether the following sequences are arithmetic or geometric, and then determine the function, like the equation, I guess you could say, for the sequence. If you are in regular, you are not going to determine how many terms are in the sequence. You're only going to do that if you're in pre-AP. And again, this practice is not graded. It's not mandatory. So just do as many problems as you think that you need to get comfortable with it. The key is on Google Classroom. I'm going to go ahead and do just like one type of problem from each section so that you have kind of an idea of how to do it before you look at the key. So for number 1, it says determine the first 4 terms and the 10th term of the following sequences. So I'm going to find A1, A2, A3, A4, and A10. All you're going to do is substitute the n. So substitute the n here and the n here for whatever number you're looking for. So if I'm trying to find A1, I would rewrite my formula, but instead of putting the letter n, I'm going to replace it with a 1. So that's saying -1, 1 plus 1 is 2. -1 squared is -1 times -1. A negative times a negative is a positive, so this will be +1. A2, same thing. You're going to replace the n with a 2. So this is -1 to the 3rd power. If I have 3 negative signs, that's a negative, so this would be -1. For A3, you're going to replace n with 3. -1 to the 4th. 4 is an even number, so 4 negative signs comes back positive. For A4, you're going to replace n with 4. -1 to the 5th. 5 is odd, so that comes back negative. And then A sub 10, just replace n with 10. negative 1 to the 11th, that's going to come back negative. So the way that you're going to write this is just write out all of what you have and write it with a comma. So you've got 1, negative 1, 1, negative 1. And then to represent the jump between the 4th term and the 10th term, you're going to put comma, dot, 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 and then the A10, which is negative 1. And that's how you would write your answer. Okay? So those 4 are for regular and pre-AP. You're just replacing N. So let's do number 5 here. So you're going to determine if it's arithmetic or if it's geometric. So on this first one here, if I go from 6 to 10 and then 10 to 14, I'm adding 4 each time. So since I'm adding to go from one number to another, that means that this is arithmetic. And the arithmetic sequence, this is the formula. You can look back at your notes for it. In this case, A1 is 6 because 6 is the first term, and our difference is 4. So you have A sub n equals A1, which is 6, plus D, which is 4, times n minus 1. And that would be your formula. So for my regular kids, if you can do that, you're done with the problem, just stop there. For the pre-AP kids, you guys need to determine how many terms are in the sequence. So you're going to take the last number, the 102. A sub n is 102 because some term in my sequence, my last term is 102. So you're going to take 102 and you're going to set that equal to the rest of your equation. And then you're going to solve that for n. So you're going to subtract 6 from both sides. And then I'm going to divide both sides by 4. And you get 24 equals n minus 1. Add 1 to both sides, and you get n is equal to 25. So that means that there are 25 terms in the sequence. All right, let's try this one. So for this one, if I go from 2 to 6 and 6 to 18, I can't add by something. If I do 2 to 6, I would be adding 4. But if I go from 6 to 18, I would have to add 12. So it's not arithmetic because I'm not increasing or decreasing by the same amount each time. Instead, to go from 2 to 6, I can multiply by 3. And to go from 6 to 18, I can multiply by 3. 18 to 54, multiply by 3. So since I'm multiplying, this one is geometric. So my formula for geometric looks like this. A1, the first term in my sequence, is 2. And R, my common ratio, or the number I'm multiplying by each time to get to the next term, is 3. So we've got A sub n equals 2 times 3 raised to the n minus 1. And that's my formula. So regular kiddos, you can stop there. You're done with the problem. Pre-AP kiddos, you guys have to figure out how many terms are in the sequence. So I'm going to take my last number. That means that A sub n is equal to 4374. So I'm going to take 4374, set it equal to the equation I just came up with, and then I'm going to solve. So I'm going to divide both sides by 2. So 4374 divided by 2 is going to get us 2187. And I've got 3 raised to the n minus 1. Now the tricky part here, I have the n minus 1 in the exponent, and I need to bring it down. So I'm going to take the natural log of both sides. Okay, so using my power rule, I can bring down the n minus 1. So I'm going to have ln of 2187 equals n minus 1 is now in the front times 3. to get rid of the 3, because I'm trying to get that n minus 1 by itself, I'm going to divide both sides by 3. You put that in your calculator, and you're going to get 7 equals n minus 1. Add 1 to both sides, and you're going to get that n is equal to 8. So there are 8 total terms in that sequence. On the last page, the very last question is a pre-AP extension piece. So you can look at the key on Google Classroom for that, but my regular kiddos don't even look at that one. For your reflection questions, just to kind of get you thinking about what you're going to be answering, I want you to be thinking about what the difference is between an arithmetic sequence and a linear function. So an arithmetic sequence, remember, this is our equation. Okay. A linear function would be something like y equals 3. Linear just means that it's a line. So I'm just going to be set equal to some certain number. Thinking about the arithmetic sequence here, if I were to take off this entire portion, I would have a sub n is equal to a1. So that would mean that I would have a function that is just equal to some number. That is a linear function. So the difference between the two, your difference is 0. You don't have a difference between the terms. For example, if my sequence was 3, 3, 3, the difference between all of these terms is 0. So if I were to try to make a sequence out of this, I would say a sub n equals a1 is 3 because 3 is the first term. My difference is 0. Then I have n minus 1. Since this is 0, all of this is gone, because if I multiply 0 by anything, it's just 0. So I end up getting a sub n is equal to 3. Okay, so the difference between the arithmetic and the linear, the arithmetic is going to have a difference that is not 0, and a linear function has no difference between the terms. The difference is 0. Some other things that you should be looking at, the first 4 questions from these practice problems, they're going to be good to help prepare you for your reflection questions. And then the second set of problems where you have to write the formula given a sequence of numbers, that's going to help you as well. If you need anything, please email your teacher. Thanks for watching and have a great week.